Chris Benson, PhD from MIT and co-founder and CTO of Istari Digital. He spent years at the U.S. Air Force nuclear deterrent programs before building a company dedicated to making AI-assisted digital engineering safe by design. So great to have Chris present, and looking forward to what you're going to say.
So first off, thanks so much for the invite from the team over at Seaside. I'm very excited to walk through some of the discussions here. Title of the talk here today: Move fast, don't break things. AI is fast. How can we help make it safe? We're seeing a lot of folks using AI to help their engineering teams move faster, especially in these model-based and system as code workflows. So basically, it's allowing us to move fast, but how are we making sure we're moving safely? And we're seeing a lot of folks who are also at the same time moving from SysML v1 to SysML v2. And we're seeing a lot of these migrations, and a lot of folks are trying to use AI to do that. But there's a lot of risk in that because generated engineering artifacts, they still need to be checked, tested, and trusted. So today I'm going to do a very quick presentation. I know I burned 5 minutes on IT difficulties, talking about how you can use probabilistic AI guides and deterministic guardrails to make sure that if you are using AI in your model-based system engineering journey, that you can make sure that you can trust the data coming out of it. So real quick, we see a lot of customers who come to us and say, hey, we got a bunch of SysML v1 models. We want to move to SysML v2. Okay, sounds good. So I don't think we're the only ones hearing a lot of these kind of questions. And so I will tell you that a lot of folks, when they go approach this, they say, well, hey, can AI help with this transition? We also get this question quite a bunch. And so a lot of people's first approach to doing this says basically, well, can I just drop this MD-zip file, my SysML v1 model? Can I just drop it into ChatGPT and get some nice SysML v2 out of it? But actually, it will do that, right? So I don't know if how many of you folks have actually tried that, but it did not used to be able to do this about a year ago, maybe even 6 months ago. But now you can just drop it right in, and it'll go through it, and it'll give you a whole nice of things. Now it says it'll give you a best effort SysML v2 textual package, and that blocking itself is one that really should start to make sure, I don't know, should I really trust this data? Should I trust a best effort text package as a model that I'm going to start to trust? So now it says it gave us a best effort SysML v2 textual package there. And it also gave us conversion zip and a text file and a README markdown. It gave us a whole bunch of different things, which was really interesting. So we dropped all those into Istari, and honestly, it looks pretty compelling. It looks like a pretty nice best effort experiment here. But the question is it good? Is this best effort actually good? How can we tell that it's good? So we have this agentic translator. And I'm going to introduce 2 ways that we're going to go check if it's good. The first is deterministic guardrail. And deterministic guardrail is basically, you can think of it as basically just a Python test that will check critical aspects of the model. So what are the critical elements that we pulled from the SysML v1 model? Did each critical element make it into the SysML v2? And is each one of those critical elements still connected to its required system relationship? So this is deterministic, which is nice. It says, hey, if I have element in v1, do I still have element in v2? You could also use a Seaside checker as SysML v2 evaluator. And so this is one where they have the Seaside Python library. You can actually drop it in and say, hey, is this good or is this not? And so what we did is actually, I ran this test and I created 5 deterministic guardrails for this example, this agentic pipeline. And it looks through, it looks for silent drops. It looks for the inventory from all the different types of information that was pulled out of the V1. It uses the Seaside validator. It looks at those critical connected elements, and it makes sure that it can cite those sources, which is also useful to know that it's actually coming from the real models you're working with. So 5 deterministic guardrails for one agentic translator. But there's some things that actually still will get through the cracks unless you also can use an AI to check the work that you're doing from a probabilistic guide perspective. So what you can do is instead of just using AI to do the translation, you can also use AI as basically an adversarial AI to check what you're working on there. And so the probabilistic guide is basically an LLM rubric that scores whether those model elements were translated correctly. So did the chosen SysML v2 type follow directly from the v1 evidence? Were there other types considered before making that choice? And did the check avoid any risky guesses when a wrong mapping would be costly? So it'll go through and the AI can actually go evaluate each one of these different things. And so we actually built two of these probabilistic guides for this simple pipeline that we built. One was the element classification, and one was the intent fidelity, right? Does the V2 preserve the meaning of the V1, or do we just do kind of a blind movement over there? This is how you kind of help catch some of those things that a human would check that that just the straight translation would not check. So going back to what we're saying, there's one agent to perform the actions, and then we have 7 different ways to check the output. And so that's a ratio that probably, I don't know, we're starting to see is, you're doing 5 to 1 and 10 to 1, translating between the checks and the actual actions. So that we can actually run all 7 of those tests against that ChatGPT generated SysML v2. This is here showing the provenance graph in Istari, showing how we can track those tests against it. And 3 of those tests passed, 4 of those failed. And you can see it right as you see it right here. Just a nice JUnit report. And then I asked Claude to summarize the test results because I didn't want to go read through it all. We only have 10 minutes. So bottom line is ChatGPT produced plausible looking SysML v2, but overall this external compiler rejects it. So the Seaside folks, thank you to the Seaside folks. You guys are the gold standard on that one. And so you all rejected it. And so, well, it seems like we can do this translation not without checking it. But then we kind of took it one step further. We said, well, what if we fed that feedback back into the original AI action? Well, turns out you can just take that one, and with one loop of this, we can go from actually it doesn't compile and it doesn't pass most of those tests to now it has 5 that do pass. 2 of those still fail. And you can build that iterative loop and keep rerunning those tests until it becomes until you pass all of the different tests. And in the end, we never were able to run this until it will compile for Seaside in the SysML v2. So now we went from straight SysML v1 to SysML v2 using that pipeline. And there are still some flags because it's never perfect, but it's okay. As long as you know what the errors are, you can either go back and fix them or you can go accept them. And so the bottom line up front is if AI lets us move fast, how can you make sure you're moving safely? There's 2 ways you can do this. You can use deterministic software tests that define the reliability of your data, and you can use some probabilistic AI guides that evaluate that data against a predefined rubric. So our number one recommendation is if you're going to be using AI in any sort of these model-based engineering aspects, make sure you're running these checks and make sure you have the provenance. Otherwise, you're going to start running it into big challenges with AI making mistakes on your critical models there. So with that, I will pause and see if there are any questions.